Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends at Linode. With their new managed database service, you can launch a production-ready MySQL, Postgres, or MongoDB cluster in minutes with automated backups, 40 gigabit connections from your application hosts, and high-throughput SSDs. Go to dataengineeringpodcast.com/Linode today and get a $100 credit to launch a database, create a Kubernetes cluster, or take advantage of all of their other services. And don't forget to thank them for their continued support of this show. Data teams are increasingly under pressure to deliver. According to a recent survey by Ascend.io, 95% reported being at or over capacity, with 72% of data experts reporting demands on their team going up faster than they can hire. It's no surprise they are increasingly turning to automation. In fact, while only 3.5% report having current investments in automation, 85% of data teams plan on investing in automation in the next 12 months. That's where our friends at Ascend.io come in. The Ascend Data Automation Cloud provides a unified platform for data ingestion, transformation, orchestration, and observability. Ascend users love its declarative pipelines, powerful SDK, elegant UI, and extensible plugin architecture, as well as its support for Python, SQL, Scala, and Java. Ascend automates workloads on Snowflake, Databricks, BigQuery, and open source Spark, and can be deployed in AWS, Azure, or GCP. Go to dataengineeringpodcast.com/ascend and sign up for a free trial. If you're a Data Engineering Podcast listener, you get credits worth $5,000 when you become a customer. Your host is Tobias Macey, and today I'm interviewing Vishnu Venkataraman about building the data platform at Credit Karma and the forces that shaped the design. So, Vishnu, can you start by introducing yourself?
Hi, I'm Vishnu. I lead data engineering at Credit Karma. I've been here at Credit Karma for 8 years now. And prior to Credit Karma, I did early stage CTO roles, Games 24/7 and Nykaa back in India before I moved over to the Bay Area and started working with Credit Karma. And I'm excited to be here.
And do you remember how you first got started working in data?
You're taking me back, Tobias. So I think when I did my undergrad, I did a little bit of fuzzy logic in application to managing dynamics of systems, controlling dynamics of systems. I think that's really where I started a little bit with AI. I had an opportunity to get into neural networks right after that, but I decided to not get into it. Maybe that was a mistake in hindsight. And then when I started working, I was more a early stage startup engineer. I just went the way where the company wanted me to go. Then later on, when I started my CTO role at Games 24/7, we built out the initial product, and gaming being gaming, there's a lot of data that gets used for a lot of decision making. And at that point of time, there was a strong need to build a BI framework that allowed us to keep making the right business decisions. I think that's probably where I got started out into managing data products and understanding the value of data products. And after that, I did like product recommendations at Nykaa. And then later on at Credit Karma, I touched all aspects of data, building out data pipelines for collection of strong data, building out an experimentation platform, building out a recommendation systems teams, machine learning teams, helping data science teams in recommendations and fraud, going the whole gamut.
And so in terms of your work at Credit Karma, can you describe a bit about what it is that the business does and the role that data plays in the organization?
I think when our founders started, one of the problems that they were really looking to solve was the credit score was one of the single most important data points that was being used by banks and fintechs to decide whether someone should get a debt product or not. And users needed to pay money to the bureaus to get access to their credit score. And they felt that the system was really not working in favor of the users to be able to keep their financial health in good place. So that's where it started out with. And one way I visualize to myself is like, I use Google Maps every day. I just did a Disney trip, and without Google Maps, I couldn't have made to Disney. I had trouble even with the Google Maps going into Disney. And when I start out Google Maps, if I don't have like the GPS tracking on, like to detect current location, I have to tell Google, this is my current location. Even with respect to a financial journey, I think of it as we all need to know where are we today. If we do not know where we are today, we can't really do anything much, improve our situation, or even understand whether we need to improve our situation. So that was the big unlock for Credit Karma, where we bought credit scores and reports from the bureaus on behalf of our members and gave it back to the members to access for free. That's where it started out. And we realized that there were a lot of other challenges that our 130 million plus members have in using the data that we were putting in front of them to make their own decisions that matter to them in their everyday lives. And we started building a lot of applications on top of the data, which allows our members to really understand how to move forward with their lives in terms of financial progress.
In order to be able to support this data-led organization, I'm curious if you can talk to the team topology and some of the ways that you think about the breakdown of roles and responsibilities along the continuum of data professions and data stakeholders and users, and how that has grown from when you first started to where you are today.
Yeah, I think when I first started out, we had all our data in Vertica and we were managing the Vertica clusters ourselves. So that was part of the database administration team. And like at that point in time, we had a few data scientists spread across the organization. We didn't really have a full-fledged data engineering team or a full-fledged data science team in any way, form, or fashion. At the same time, the company was already into data science and help using data science to help our members to get more certainty in terms of which products they can get approved for, because we had a lot of traction in the market in terms of a number of credit card applications and personal loan applications and approvals that were flowing through our funnel. So it was very application oriented, and we were focused on like building out the right member experiences with the data. We were focused on availability for the member experiences. I think over the years, we have built out like fully fleshed BI teams. We have built out fully fleshed data science teams. Recommendations has become a big use case, which really allows us to grow our business. And to support all of that, over the years, what we have really done is like we have split ourselves up into like horizontals and vertical teams. One clear demarcation is there are one set of teams which are focused on partnering very closely with our analysts, analytics organization, and business intelligence organization. And there is another group of teams which are focused on partnering very closely with our data science teams. And data science itself is spread across recommendations and fraud. Maybe I'll start a little bit of the horizontal teams that we have to support all of these use cases. One is like we have an ETL team which helps application teams who are all into microservices to make sure that all the data that is getting collected from the operational databases is like getting transported over into a data warehouse, which is BigQuery. We made the change to BigQuery a few years back, and after that, it's been really beneficial for the entire organization. And then once the data lands in the data warehouse, we have a lot of other teams which are picking that data. The BI teams are picking that data and converting them into like data sets, high quality data sets, which are usable by the rest of the business. And then there is a machine learning infrastructure team, which has some sub teams which are focused on building machine learning data sets, which then becomes a starting point for our data scientists to start building their models, to do their exploration, start building their models. Our data scientists also end up exploring new data that is getting ingested directly from the warehouse, but more often than not for their regular day-to-day work, they can just use the data sets which are like cleaned and well maintained directly from what is being made available by the machine learning infrastructure team. The machine learning infrastructure team also supports a framework internally, which we call as Vega, which is a way in which data scientists can easily design, develop, test, iterate, and deploy models into production. When we started building out Vega, we were looking at TensorFlow closely, and we started using some aspects of TensorFlow, and TensorFlow ends up getting used as our model training and as well as like model scoring part as well. And then once these models get deployed into production, whether it is for recommendations use cases or fraud use cases, now we need a model serving team that is able to operate at scale. So today, I think we do like 58 billion models that are scored every day. So there is a team which is focused on the infrastructure for model serving. And then there is also a corresponding team which is focused on making sure that there is data, current, fresh data available for all the models to get scored on top of. That's a lot. And I think let me just like maybe touch on the data science teams as well. So we have a data science team focused on certainty. This is more about helping our members get an understanding of what are the chances that they're going to get approved for a particular product, whether it's a very good chance or a good chance or an excellent chance. And then we have a data science focused on machine learning driven notifications. What email campaigns are most relevant to be sent to a particular member on a daily basis. On every day, we are running through all our campaigns to check whether we should even send an email or a push notification or not. And then there is a third team which is focused on ranking, which gets used in our recommendation systems, which is where all the use cases come together to power our member experiences.
As far as the specifics of the data that you're working with, obviously it's working in the financial space, so there are a number of regulatory aspects to it. But I'm wondering if you can talk to some of the, I guess, operational characteristics of it in terms of the 3 V's of volume, variety, and velocity, and some of the types of integrations that you need to maintain for being able to source the data, and maybe some of the structure of the data. So whether it is, largely textual, or if you're dealing with, binary data, or some of those kind of operational and analytical characteristics of it.
I think in terms of the sources of data, like I mentioned earlier, we buy members' data from the bureau on behalf of our members and make it available to the members and make it available for our internal systems. Now, depending on the bureau, depending on the data that we are getting from the bureau, some of it is like daily, some of it is like weekly, some of it is a couple of times a week. Also in real time, if there is a immediate change that is happening. So whenever I have a hard pull that happens on my credit report, the bureau immediately lets Credit Karma know, and then Credit Karma lets our member know that there is a hard pull on your report. This is actually the core data on which a lot of business functions are built on top of. And this has a lot of critical information, not just for our business, but also for our members. This is what our members are using to understand whether they have disputes on their report, which is pulling down their credit score. What are the recent pulls? When are these credit report pulls getting off my hard pulls, getting off my credit report so that my credit score can get better? When I'm making payments, am I making payments in time? This is where all of our user facing applications get built on top of. Like I mentioned earlier, we have 130 million members. So, as you can understand, there's a big volume of data that is coming through. And this is bureau data, which is like used by all the financial institutions. So, the schema aspects of the bureau data and how it changes, when it changes, is like pretty static, I would say. Changes a little bit every few years. And then when it changes, there is just like a massive amount of work that all the institutions as well as we end up doing. We get a lot of support from bureaus to do it, but there is still, it's an expensive thing to go through. And then I would say, while this is a lot of volume, we have more than 8 million visitors to our using our app on a daily basis, more than 8 million, which means that there is a lot of behavioral data that is also getting collected and made available to our systems to understand like what the users are looking at, which are the items that they are more interested in, which are the articles that they are more interested in. And then the last bit of data is actually what I think of as like content data, which is what we end up recommending. And content or items, internally we call them generally items. So items are what we end up recommending to our members. Now these items could be credit card or a personal loan, which means the items are controlled, the changes to the items are controlled by the banks who have these financial products in our marketplaces. Or it could also be content that we have internally authored, which can also be recommended to our members. Some of the authoring is essentially a big part of our member experience. And maybe I can give you an example here. An example here is that I just had a recent hard pull on my report. And as soon as I have a recent hard pull on my report, then we want to highlight it to the user that this is an area that you want to go check on to make sure it's a hard pull that you request it, because nobody is allowed to pull your report without the member's permission. So if the member has not given permission and a hard pull has happened, so that means there is a chance that their identity might have been stolen. And it's important for the member to know immediately, and important to put it in front of the member as much as possible. We recommend that we put that in front of our member. So that's content data. The content data, it's like pulls together various attributes from the bureau data, pulls together various attributes from the behavioral data, and then we just like stitch it together and put it in front of the members. This data, I would say, it's not a large number. It doesn't change often, because generally it's changed by humans, and either humans within Credit Karma or humans within the banks, and it doesn't really change a lot. But it's very powerful to help us understand what's most relevant to our members, and we end up doing a lot of fun things with the content data. It's actually an area that we are trying to go deep into going in the future. And in terms of the format of the data, I would say a lot of it is like tabular data. With the content data, we are getting into like some amount of textual content, because when you see a credit card offer, you see a bunch of marketing bullets there. And similarly, I talked about our notifications data science team. So when we are sending out an email or a push notification, there's a lot of text content in there that we want to start using to understand like what's most to improve our relevance of our content that we put in front of our members.
As far as the different categories of data that you're working with, I'm wondering how that influences the complexities and challenges of how to work with that data and some of the cycles that it introduces. Like you were mentioning with the bureau data, there are periodic updates where you then have to go and adapt your transformations to be able to account for the shifts in those data sources. And I'm wondering how the different kind of data categories and data sources combine to generate some of the kind of complexity and impose constraints or add requirements for the architectural elements to be able to support those flows.
I think pretty much from very early on, we wanted to make sure when a member comes to Credit Karma, they have their most recent data in front of them. We did not want to make them come back and then say, hey, come back tomorrow, and then you'll see a refreshed report, and then show them stale data. We wanted them to have the most updated report and data in front of them. That is a very, very key design decision that got made a long time back. And it's kind of natural, right? So like if you're going to check out for a flight price, you want to know the recent flight price that you're going to get rather than like yesterday's flight prices, right? Or as well as like availability. So what that means is when our members come to the app, we are getting in touch with the bureau. So we have built out the bureau integrations. We are getting in touch with the bureau and working with them to get the data as quickly as possible, and then running through some transformations and processing and putting it in front of the member. Now, what this means is that correspondingly, we needed to make sure that all the models that we are using to serve recommendations to our members also uses the latest data. So which means that we had to make investments in real-time model serving. That was like one of the first things that me and my team did as soon as I joined. The first year, we built out our real-time model serving infrastructure to make sure that the users can see the latest data, the users can see the recommendations based on the latest data immediately. We made this investment when model serving and model serving infrastructure was not really like a thing out there. A lot of people, like I'm talking 2014, 2015, a lot of people were still doing like batch model serving, do like batch data, and then like build your models, run your data quality checks on the batch data, and then run your models on top of it, use cache those model scores and make it available. We couldn't afford any of that because of some initial design decisions that we made. The second big, not really say a challenge, it's just like an important critical design decision that we have is we do not use any PII in our models. The credit report data has PII in it. We make sure that the PII that we get is essentially for our member consumption and it's not used anywhere else. So, from a security perspective, a lot of these things are locked down. And the area of like recommendations, the area of data science and machine learning for all of these use cases, they do not get access to any of the PII data. So we had to build out like separate zones to make sure that we have like tight control over all of the data that is moving across from one zone to the other, and made sure that all of the monitoring is in place. So these were all like very early initial design decisions that were made that allowed us to make the right investments at the right time, I would say. I think one of the bigger challenge really was when I started out in the initial time, we were not yet in the cloud. We were in our own data center. Like I mentioned earlier, we were running our own like Vertica cluster. And I remember a point in time when our data scientists needed to pull together a training data set, and they would collect data processing jobs over weekends, over a month. And then they would say, okay, I'm done with this month of training data set collection. Now I can go build my model. And then once we started moving into the cloud, we had obviously elastic compute resources. We were able to get all our data into BigQuery, which meant that the management aspects of our data warehouse was something that we outsourced to Google. It was a big, big lift for us because data scientists could then get into their job of like exploring the data, getting their training data sets together very, very conveniently and build their models quickly. So I would say those are probably like some of the challenges from the initial days that I think are probably important to bring up here.
RudderStack helps you build a customer data platform on your warehouse or data lake. Instead of trapping data in a black box, they enable you to easily collect customer data from the entire stack and build an identity graph on your warehouse, giving you full visibility and control. Their SDKs make event streaming from any app or website easy, and their extensive library of integrations enables you to automatically send data to hundreds of downstream tools. Sign up for free today at dataengineeringpodcast.com/rudder. And in terms of the different data products or derived data assets that you are generating, I'm wondering how you approach the question of determining the return on investment and identifying what are the most crucial aspects that require high uptime and reliability, and what are the pieces that maybe can have a looser SLA or something, and how that influences the way that you structure and orient the work around how those assets are maintained.
Maybe I'll start with the data applications. In terms of the applications about providing the greatest ROI for us is we monetize by recommending financial products to our members. And when our members get approved and when they take the financial product is when we get paid. So that's the basic business model, which means that anything related to financial product recommendations is top of mind for all of us, and all the data that gets used, all the models that gets used to drive our financial product recommendations is like going to directly add to our top line. The other big use case, I mean, we have a bunch of other use cases. I'll probably touch on like one more big use case. The other big use case is on the notification side. Notifications is when we send out an email or a push notification to a member and telling them that like, hey, something's changed on your credit report, or here is an offer that you're eligible for. So some of it is like related to their financial health. Some of that is related to like the financial products that they are now eligible to get that they previously were not eligible to get. So these are probably the two biggest data applications that provide the biggest ROI for us. And in terms of the SLAs related to these data sets, like I mentioned earlier, the when you're getting like real-time credit data, when the user is on the app, you want to use the freshest data. You want to be able to make sure that the user has a snappy user experience. There are definitely constraints in terms of the models that we can use there. There are constraints in terms of the amount of data that we are able to push through. And so far, we have done a great job of managing that, I would say. But at the same time, there are like a lot more use case data and derived use cases that are coming up, which are becoming more complex for us to handle online all the time. On the notification side, because it's a process where it's not like someone is sitting up and waiting for an email or a push notification from a Credit Karma every minute of the day. So we have an opportunity to do things in a way where the SLAs are a little looser. We want to make sure that we are able to get in touch with the members on some situations quickly. Like I talked about the heart pull, you want to be able to immediately let the user know about the heart pull. But if you're telling them, hey, this is how your monthly spending looks like, or this is how your monthly credit utilization looks like, you don't need to really worry about like a minute by minute SLA. So we end up doing like more on the batch side for the notifications. And the SLA is a little looser. We can take our time to make sure that our data is in a good place. We can use some of the machinery that Google allows us to use, data flow, to be able to process things in batch and do other fun stuff in that area as well.
In terms of the architecture of your data platform, you mentioned that in the early days when you first started, you were largely running your own Vertica clusters, and since then you have migrated into the cloud. I'm curious if you can talk to the different, I guess, epochs of the data platform architecture and what were some of the motivating factors that led to some of those transitions or transformations, and how you thought about the build versus buy process along each of those stages.
I think some of this is about evolution of our use cases and evolution of what we can do with the data. Some of this is about as we are able to build more teams as the company grew, we were able to build more teams to focus on like specialized problems. In the initial phase, a couple of years, like I mentioned, it is more about moving from our own data centers to the cloud, primarily from a offline perspective, where we were able to get like all of our data into BigQuery and start like processing all the data within BigQuery. Then I think one of the other early investments that we made that I talked about was our real-time model serving system, which continues to operate at a large scale today. The other big investment that we made was to make it easy for people to collect data across the app, irrespective of whichever product engineering team was doing. So I think we had this concept of consistent tracking. So we made like a very initial investment in like getting that right, so that it's cheaper for our product engineering teams to understand, cheaper for our product engineering teams to make sure that the data that they are collecting is good data that they're collecting, and for them to get like immediate feedback if there's something is wrong with the data collection process. So that is like one of our really critical investments that we made very early on. Then we started getting into the world of, hey, we are getting a lot of this data. Not all of this data is being used everywhere. So there was some amount of data that people had explored, some amount of data that they are not explored. So we wanted to make it easy for our data scientists to use all the data in our models. That is where some of the training data set creation that I had mentioned earlier in one of our questions that came up, where we said like we need to make sure that we are making it easy for our data scientists to use all the data rather than making it hard for them. So I think the investments in custom created training data sets, we call it like modeling data stores, was like an important thing that we allowed for our data scientists to continue to iterate. I would say the investment in our machine learning framework, which allowed our data scientists, as the number of data scientists in our teams grew, the number of use cases grew, how can they easily deal with large amounts of data while at the same time getting into like building deep learning models. Initially, we were using a lot of random forests and trees. I think we moved into using a lot of deep learning models after that. So when we moved into deep learning, how can we allow our data scientists access to powerful frameworks like TensorFlow, not having to worry about like, is my model training going to take like a week or will it finish quickly? So all of them like self-service way of building their own models and like having the control over their own destiny. And then I would say then we started getting into like applying all of the machinery that we talked about here into other use cases, which were in notifications, something that I brought up earlier. And also we started getting into like a lot of the like internally authored content that we started putting in front of our members, that we started also having to collect a lot of behavioral data about, and our initial investments in consistent tracking paid off here as well in terms of collecting behavioral data for our members. Along the way, I think one thing I missed out was our investment in our experimentation platform. I think it is actually one of the early investments that we made, which allowed data scientists to run model experiments very, very cheaply, and set up our experimentation practice in a really good way. And everything today gets like determined by experiments. And you have to, when you start out the experiment, you're talking about the metrics that you're going to move. If you do not have that documented, you're probably not even going to get allowed to get that experiment out in production. Even the experimentation system is like a self-service system that we built out, and like pretty much like one third or close to one third of the company has access to the experimentation system, either to view or to launch or ramp experiments. I would say those are probably like some big investments that we made along the way.
Another interesting aspect of the work that you're doing with your data is that in addition to being a data-led company, you're also investing very heavily in the data science and machine learning capabilities. And I'm wondering how that focus on machine learning and data science use cases influenced some of the architectural decisions and the ways that you thought about the flow of data through the company, as opposed to a company that is primarily focused on analytical, like report-based uses of data.
I think one key point that I'll bring up here is like when we built our first generation recommendation system, one of the things that was a very clear focus on was when someone is making a request to the recommender system, the recommender system has two jobs to do. One is to serve the most relevant recommendations to the member. The second thing is to collect data about the current context, all the data that was used by the recommender system as part of the current context in making that recommendation. Because we knew that when you start getting into like data science and machine learning, you need access to that system level data that allows our data scientists to look at data at that point in time. So we made a deliberate design decision where we wanted high data consistency with respect to the data that was getting collected for our data scientists to use. Because in normal situations, this is like point in time data that is probably available in different data sets that you can like stitch together. It's probably might be cheaper to do that, but then you get into like a lot of data consistency challenges to be able to stitch all these data sources together. So we made a very key design decision where a recommender system was continues to collect point in time context data about the entire data. What is the user's data that you have in access? What are the behavioral aspects of where is the user currently in the app? What is the state of the content at that point of time? Because content can also change. We were collecting all the data in one place, and then that is a big decision. It's a big investment that we made, we continue to make in making sure that we are able to allow our data scientist teams to not worry too much about consistency issues when you're trying to pull together. They still have to pull together some additional data points from other data sets, but like it's really set up to be minimum. I think that's probably one big design decision that I would call out here.
Modern data teams are dealing with a lot of complexity in their data pipelines and analytical code. Monitoring data quality, tracing incidents, and testing changes can be daunting and often takes hours to days or even weeks. By the time errors have made their way into production, it's often too late and the damage is done. Datafold built automated regression testing to help data and analytics engineers deal with data quality in their pull requests. Datafold shows how a change in SQL code affects your data, both on a statistical level and down to individual rows and values before it gets merged to production. No more shipping and praying. You can now know exactly what will change in your database. Datafold integrates with all major data warehouses, as well as frameworks such as Airflow and dbt, and seamlessly plugs into CI workflows. Visit dataengineeringpodcast.com/Datafold today to book a demo with Datafold. Another interesting aspect of the work that you're doing is that because you are dealing with financial information and you're dealing with data products that can influence the ways that your customers think about their finances and approach their spending and investments, obviously there is a lot of need for ensuring that the information that you're providing is accurate and understandable. So two forks to this question, where one is understanding how you approach the data quality and validation of the assets that you're building. And then the other one is how you approach the user-facing design and presentation of those data products and data assets to ensure that they are being understood and interpreted correctly by those end users.
Yeah, that's a difficult and hard problem for us because credit data is pretty complex. And to be able to put it in front of members in an understandable form is always a hard challenge that our designers are helping us with. And I think it's an evolving thing that we are always going to be working on. Saying that, on the more on the data reliability and quality side, I would say it's like making sure that like each of our teams who are involved along the way, whether it's like from right from the point of like data ingestion, even earlier, even working with our bureaus, to making sure that they are able to help us on data quality and making sure that we are partnering with them on data quality. But internally within Credit Karma, right from the point of ingestion, it's more about, as like I talked about, like some horizontals and verticals, it's more about making sure that people have access to the right tools, people have access to the right mechanisms and processes to be able to monitor and make sure that they're taking the right actions when something goes wrong. They can detect and quickly take actions when something goes wrong with respect to our data. I talked a little bit about the content recommendations earlier. And one of the interesting things that like one of our teams did was whenever there was a challenge with respect to like a particular content recommendation, they would create a site incident which would actually tell the people responding to the site incident an estimate of the value of the content if the recommendation was not working properly. So what they really did was like they look at like historical data over the last few weeks in terms of how much revenue was attributed to that particular content recommendation, and then put that in front of the people who are dealing with the site incident so that they can deal with it in the right level of urgency. This is an area that I think we are always going to be paranoid about, because we understand that when we put data in front of our members, we are asking them to put their trust in us and trust in the trust in the company, and members' trust in us is like paramount for us. It's really allowed us to have all the success. So this is an area that we are constantly looking to evolve, constantly looking to invest in. I think that there is so much that we can do here. One other aspect I can also bring up is we invested in anomaly detection. We were like one of the early users of Anodot. So a lot of our data and business metrics, we link it up to Anodot, and we have made it like really self-service so that a lot of internal teams can use that for anomaly detection, which allows them to also catch a little bit of the unknown unknowns, right? So Anodot can provide us some anomalous patterns in the data, then the teams can react quickly and figure out like what the problem is going on.
On that point of anomaly detection, and going back also to your earlier comment about the periodic updates from the bureau sources, I'm wondering how the, I guess, cyclical aspects of the data updates in some of your source information influence the pieces of information that you need to feed into the anomaly detection to say, we are expecting this update, or, allowing the anomaly detection algorithm to account for those cycles, while still also saying, we want to understand within those updates if there's something that appears anomalous, because I'm sure that there are also cases where the source data isn't 100% accurate and you actually need to go back and work with some of those bureau sources to correct those assets.
Yeah, I think as far as anomaly detection is concerned, it's actually expensive to run it at a user level. We end up doing it more at an aggregate level to get a sense of the overall data set that we are ingesting, try to understand like are there like any big changes at the overall aggregate level. And when we see some challenges, I think we have, like I said, like really tight relationships with the bureaus. We have like run books that we are shared with each other. We just like work directly with them, with their engineers, to our engineers work directly with their engineers to bring things back to normal. And there is a lot of data that we are getting in real time from the bureaus. There is also data that we are getting from batch. So if we find an issue with a batch, then we would much rather work with the bureaus to fix it before putting it in front of the users. and before using it as part of our recommendations and other use cases that we have. So that way, then we are protecting our business and members from data quality issues. But as we get into like more interesting things like streaming of the bureau data, where we want to focus on speed, then some of these things again become more challenging. How do you detect if you're no longer able to do things in aggregate? If you want to do it on a user by user basis, there are some interesting problems there for us to solve.
In terms of your experience of building this platform and helping to guide a lot of the evolution and architectural updates, and in the case of moving to the cloud, the replatforming, I'm curious if there have been any interesting and informative either mistakes or maybe dead ends that you went down, and some of the useful lessons that you pulled out of that experience.
So we were moving into the cloud. We were also correspondingly decomposing our monolith into microservices. So there were definitely some challenges in how all of this played together, where like we wanted to make sure that we were getting the most benefits out of the cloud. We also wanted to make sure that we are setting up each of our teams to work at like a high velocity across the organization. I would say some challenges and some decisions that we made that we probably want to relook at is that along the way, we probably invested in like some data quality monitoring investments like across like in different organizations. I think there was definitely an opportunity for us to have like a unified data quality monitoring investment that we could have made together. I think from the analytics side, they made their investment. And then on the machine learning and data science side, recommendation side, we made our investment. We could have worked together better in some of those situations. And some of it is also like each team wanting to making sure that they are able to take care of their stakeholders in the right way possible. I think these are all like lessons that you learn when looking back in hindsight, and it's always something that you can go back and correct. The other maybe mistake I would say is that when we invested in some of our self service systems initially, we provided a lot of flexibility to the people who are using the self service systems. There was always an opportunity for us to like start out with some strict guardrails and then slowly open it up as we got more users onto the system rather than opening it up right up front. I think that's probably a lesson that I will take. I think I heard last week the concept of like internally we were calling it like constrained flexibility. How can we introduce like a constrained flexibility into our self-service system so that we are setting up our stakeholders and the users of the self-service systems for success? But I heard a term attributed to Bar called control freedom or something like that. I think that is also like an interesting way to think about. We were calling it constrained flexibility. I think Bar calls it control freedom. Definitely a lesson that I have for my life in terms of how to really build and set up these platforms up for success, and then setting up our stakeholders also up for success.
In your experience of building out these capabilities and working with the organization to understand what are the needs and potential products that you can build from the data that you have available, what are some of the most interesting or innovative or unexpected aspects of that growth that you have experienced?
There are definitely lessons that have been learned outside in the world that relearning ourselves as well. But I would say one of the main challenges is to make the right decisions along the way where you are balancing cost, performance, scale. And when I say performance, there is like system performance, model performance, and business performance. And it's more about making sure that you are able to make the right investments at the right time in each of these areas. And some of these investments, if you take care of it a little later, it can be really hard. And cost is definitely an area where I think we could have made investments earlier on that we made a little later on. But once we made those investments and we've been able to operate better, we've been able to also get help from GCP to be able to manage our costs better. I think apart from that, one other area that I would also touch on is complexity. So there is always a tendency for us to introduce a lot of complexity when it comes to our use cases. How we make sure that we are balancing our investments in reliability and both on the data side as well as on the system side, along with the complexity. That's again a balancing act that as a leader that you need to be making all the time.
In your own experience of working in this space and being a leader of the data teams at Credit Karma, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
Some of our best wins that we have got along the way, there were artificial constraints introduced into the system. The constraints could be in terms of time, or the constraints could be in terms of number of people available. And we've had our best wins when we had that. And on the flip side of it, to be able to make things sustainable and last and do things well, you need to start removing some of those constraints. So that is something probably like a lesson that I've learned. And I think I used to hear from one of my bosses that, like, when you introduce these constraints, it could be artificial or it could be natural. That's when you really allow your engineers and your product managers and your teams to unlock their creativity. You have to get them to the right mindset for them to be able to stop looking beyond the constraints but operate within the constraints to be able to unlock their creativity. But some of the best wins that we've got, talked about our experimentation system, I talked about integrations for anomaly detection. I think both of those were when we introduced an artificial constraint and we were able to motivate small team to go just like do a POC and get it kickstarted out. And some of that paid a lot of dividends for the company along the way.
And as you continue to build and iterate on the platform architecture and the uses of data within Credit Karma and trying to adapt to and predict some of the needs of your users, what are some of the things you have planned for the near to medium term, or any projects that you're particularly interested in digging into?
Yeah, I think one of the projects obviously is like we just started working closely with Monte Carlo, and we have a lot of users of the data within the company now. So, what we really want to do is to be able to get all these users to have better visibility and control over the quality of the data that they're using, which allows them to make their own decisions that they want to use a particular data attribute or not, which allows them to monitor the data that they are building and they are depending on during for their day to day. So that's definitely an exciting area for me. I think the second exciting area is like, let's say we have all these systems, we have all these like high quality data. What more can we do for our members? I think there's just so much more that we can do for our members, that one of the areas that I always think about is our members solve a lot of problems. Every member have their own constraints, but they are solving their own problems. Can we learn from how one member is solving a specific problem and then take some of those aspects and then use that to help some other member solve their own problem? And it could be like a different point in time, it could be a completely different geography within the country. That's the use case that I am really passionate about, and I'm hoping that we'll be able to get to that with all the rich data that we have and the system investments that we have made along the way.
Are there any other aspects of the work that you're doing at Credit Karma, or the role that data plays in the organization, or the platform architecture that you have developed to support those use cases that we didn't discuss yet that you'd like to cover before we close out the show?
Yeah, I think maybe one more area that I can bring out is making the lives of our data science teams easy is an ongoing thing. And like building the right partnership between data science and machine learning engineers and data engineers is like something that we constantly invest in. And these are all systems and tools that mostly we've been working on building in-house, because we also want to be able to use these systems for other auditability and governance purposes with respect to models. But some of these investments are, again, I would say, nascent, and we are building it ourselves. I think we talked a little bit about the buy versus build earlier, and this is an area where I am really excited about the work that we are doing to be able to make data scientists' lives easier in terms of what kind of models they can build, how they can monitor the models, how they can deploy their models conveniently, how can they make sure that the models are achieving their intended purposes. I think that's probably an area that we have made some investments in that I didn't talk about earlier, and we are going to continue to make investments in.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I think there are a lot of tools available today, and it's more about making sure that we as leaders are able to work through all the tools that are coming up there and using it. And some of these tools are also being evolved as we speak. And I think the opportunity for leaders is to understand like how you're able to put together the right tools for your own situation and making sure that you are finding the best in class that you need for your organization at that point in time. I can't really talk about a big gap. I think we have been building out a lot of these tools. And then when I go out there and look at the market, there are like so many of these awesome tools that have been built out. I would have loved to have had access to them like 3 or 4 years back and that are coming out there. And I need to sit down and spend time. I think we started a recent relationship with Monte Carlo. We had an old relationship with Anadot. So I think and obviously we use a lot of Google managed services. So the opportunity is really making sure that you're able to pick the right tools at the right time for the business needs.
Well, thank you very much for taking the time today to join me and share the work that you've been doing at Credit Karma and your journey through building out the data capabilities and architecture and use cases. It's definitely an interesting application of data. It's always great to be able to understand more about how people have charted their own course through this constantly expanding ecosystem. So thank you again for taking the time today to join me and share your path. And I hope you enjoy the rest of your day.
Thanks a lot, Tobias. Have a good one.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.